of dielectric. Bound charge. Very, I think it's there in SU Verma. Bound charge, find the bound charge. No, is this capacitor connected to any cell? That's the first primary question. No. Then they were given charges. What were the charges given? The charges given are plus Q and minus Q. Tell me what will happen to the potential difference. This is having a dielectric slab. Potential difference between the plates will be some fixed value. Capacitance also fixed value. So now we know the electrostatics, like E is equal to V equal to potential difference equal to E into D. So what do we expect now? The electric field in the air and in the slab. So here is the slabs. This is slab. No. What should be the electric field in the region where the slab is present and also in the region where the air is present? Should be same, no? The electric field. So we will show that use taking the arrow. So the electric field strength in these two regions must be same. Let that be equal to E1 and E2. Now the electric field is same. Then what is the expression for electric field? So now what about the charge distribution? The charge distribution in this region and this region will be different. So, but you are given a charge is a conducting plate. How come conductors should have uniform charge distribution? Here, not possible. You can break up this plate into two parts. There's a one part and there's other part. Here I'll shade it so that. Oh. Okay, you'll get confused. Let it be as it is. No. Here the charge density at this point will be sigma 1. Here sigma 2. The electric field has to be equal. Any reason for that? Because the potential difference will be same. Either you measure potential difference at this particular point between the plates or at this particular point. It has to be same, no? And the separation is same. So therefore, electric field has to be equal in both the regions. This is one primary condition. So then first we'll write E1 equal to E2. Then what is the electric field in the region where the electric slab is present? Charge density by epsilon R by epsilon naught. Where in air it is sigma 2 by epsilon naught. Here the charge density already indicated sigma 1, here minus sigma 1 minus sigma 2. So therefore from this sigma 1 is equal to epsilon R into sigma 2. Keep it here. There's a one primary equation which we'll be using. Then what is the total charge given to plates Q? So what is that Q should be equal to? Sigma 1 into L into X. Because what is the, hope you are able to imagine this what, and the remaining distance, this will be L minus X. This is the plate. You are seeing only a line. It should be some. No. How much of charge present in this region? So this will be sigma 1, here sigma 2. Hope you are able to understand what I mean to say. The total charge on this plate should be equal to Q, and what that should be equal to? This is L. So the total charge on the plate, I'm taking about the upper plate here. The total charge present on this plate is equal to Q. That is equal to sigma 1 into L into X, sigma 2 into L into L minus. I think this particular diagram is going to really help you a lot. Then we will go for what is sigma 1, sigma R into sigma 2 Lx, sigma 2 L square So what is value of epsilon r? 4, no? Okay, 4 sigma 2 Lx. So this will become 3 sigma 2 Lx. Plate. Okay, this is a plate. No, Vinayak, Nitesh, make observation, 3D diagram. Huh? Okay, finally, there's a one more equation. What we have, sigma 2, 3 sigma. So this will become equal to how much? Equal to, okay, how much you got? 3. This will become 4, no, totally. 4 sigma 2. X equal to L by 3. I'll substitute that X equal to L by 3. Two sigma 2 L square. Okay, this is the total charge that is present. So what is sigma 2 now? Now sigma 2 we are able to bring, which is equal to Q by 2 L square. Then similarly, now we'll calculate all the things. So sigma 2 value, I got it. So what is sigma 1? Sigma 1 is epsilon r into sigma 2. Epsilon r is 4 Q by 2L square. So this should become 2Q by L square. So what are the charge density? So now how much of charge we'll find out. We are interested the charge present here. So this will become Q1 equal to sigma 1 into Lx. The charge present in this region. What is sigma 1? 2Q L square into Lx. X equal to L by 3. X equal to L by 3. So 2 cube by 3 will come final. How much of charge present in this region? Q1. The total charge given on the conductor plate will get aligned because of dielectric slab. Able to make it out? The thing. Okay, now is asking let's come to the question. Find the bound charge present on lower surface of dielectric slab. What do you mean by this? The dielectric slab is here. I will show slightly little bit because I have to show the distribution of charge. The gap is what you have to neglect. Here, the capacity is present. So here, the charge here, what happened? The total charge Q will not be uniform, will not be distributed uniformly here. It will have one distribution here. It will have one distribution here. Sir, what about in this distribution? It will be uniform. In this, it will be uniform. But the charge distribution here and here will be different. I'm writing sigma 1 and sigma 2. Now, we'll focus is asking the on the dielectric slab, what is induced charge? First, you should calculate what is the charge present on this plate. It's not Q1. Now we know if a charge is present on a plate where the dielectric slab is there, how to get the induced charge on the slab? That is what he's asking. The charge on the dielectric slab is called as a bound charge. The charge on a plate is called as a free charge. These are the conventional things which are used in the capacitors. I think we'll take one more diagram so that will be very easy for you. So this is the dielectric slab. The thickness, the gap, I'm showing it so that I can indicate all the charges clearly. Yeah. Now, what is the charge present in this region? The charge present in this region is Q1. The charge present in this region is Q2. Then how much of induced charge? Here the induced charge, it will be negative, no? And here it will be positive. And this will be negative. This idea. Now this charge is what is asking, minus QR. How to find out? Yesterday we brought one formula. What is QI is equal to? Q1 into 1 minus 1 by epsilon R. Yesterday we derived it. So what is the charge in the region where it is there? It is Q1. What is the Q1 value? Q1 value, we got it 2Q by 3. So this is 2Q by 3. 1 minus, this is 4, F naught value, I think 4. Q by 2 charge will be present. This is a charge induced on the dielectric slab. Bound charge, various name, bound charge or induced charge on slab. But you see the way he has asked, the language is also a little bit, we have to be, sir, what is that lower surface? On lower surface means the charge will reside here. If the slab is there, no, slightly below the surface will be induced charge, because the reason for that, how the dipoles will be there, will align in this way, no? So lower surface means, again, sir, is he asking this one? Yes, you can put it here. Lower surface, this upper surface, lower surface, but this charge don't show on the top. He's asking this magnitude plus QI. I agree, but you have to show this minus QI and plus QI not on the top, somewhere inside. He's asking this QI. Magnitude is what he's asking here. This upper surface of slab, lower surface of slab. But you have to show charge somewhere just inside, not on the top, because the dipole will be here, no? There's a meaning of that one. But lower surface means here, he mean to say this one. And don't show this charge here. It'll be wrong thing if you show here. Agreed? So he is asking you, okay, I want charge here. What is charge here? I think that's what we have answered, no? Complete description is there. This is there in IDO. You might have not noticed, but this is the concept of the dielectric slab, the total. So that's why I'm suggesting you, like, if you're doing revision, if you just take textbook, see what's happening now. Seniors are there, outgoing seniors are there. You might be knowing many of them. Ask them how you're revising, how you're doing revising. Let's say I'm taking textbook, I'm revising. Textbook will contain all these things. Any of the textbooks, only 10% of information is there. And you are, in spite of teacher telling, notes you have put in dustbin, total over. Then definitely what happen, you'll be in big trouble. No, you're going to land in a big trouble. Your revision will become incomplete because of these things. Because the thing which are most essential are dumped in the notes, because we cover so many things here, so many ideas are there. So you ask how many of them are having notes? Nobody is having notes. Nobody has gathered. This happens every year. You are also going to do same donkey monkey activity. See, textbook is what? Only information, not possible. You can't revise from the textbook. It's only 5% of that one. The teacher notes, what all class notes is there, will gather so many things. So I don't know what will happen to you, that you don't accept this notes, that one. So definitely you are going to enjoy an exam. Okay, now yesterday's question, now can you answer? Yesterday's question, I'll take there. Huh? I think I can save it. Yeah. Capacitors with the dielectrics. I think the headache started from here, no? I said it's a wrong. Yeah, now you can put a very beautiful reason here. Then I said the second method is correct. Now, what be the charge? You actually are going to connect it to a cell. The charge which starts flowing here, will it be same charge here and here? See, not like separating. You have to give the conceptual. Gayatri, please do understand. Now, just now I explained the concept that you apply it here. That you have to apply it here. It's not like separating. So here the charge which comes here will split. A part of charge will flow here. A part of charge will flow here. Got the idea? Sir, how come sir, same slab? Look at here. Look at this particular thing. So a part of charge, what happened here will be different, here will be different. So therefore charge density here and here will be different. So it will, like if you connect in a circuit, here one current will flow, here one current will flow. So no question of this. Okay, got it, no? There's a primary thing from there, we have to bring it.